Okay, we'll be on our last example for this series of examples. So you have CH3, CH2, CH2, you have the double bond again. Since we've already answered that this might be from an alkene, so we could assume that this is an alkene, of course, because you have your double bond. And then we only have to look for that osmium tetraoxalate, tetra anyway, OSO4. We will only have to look for that OSO4 NaHSO3. So we go to our cheat sheet. OSO4, no. OSO4C, you have your NSO4 and OSO4 NaHSO3. So it's already NaHSO3. So we're looking already at the probably the correct chemical reaction. So sorry guys. So you have your um a part of this you would have a diol, a two alcohol. This double bond would be a single bond, and then both OH, 2 moles of OH would attach from those two carbons. So if you're going to apply it here, so again the problem would probably be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So both are 5. So that would be a 5. 1, 2, 3, 4, 5, 6. That would be a 5. 5 dicene. The reaction of 5 dicene or dicene, because that would be spelled as DEC. So that would this compound here is actually a 5 dicene. You don't have any attachment, so that would be a 5 dicene. Yeah, dicene for an alkene. Reactions of 5-decene with OSO4Na. Maybe I'll just write this as the reactant, okay? So that you will know where to find. Again, the details of that, we will leave it to the chemist. The reactions of 5-decene with this one. So what is the product? So you start from the double bond, C, that will now be a single bond. And then, of course, that H is still there and H would still there. But you would now have an alcohol, an OH here, and probably, and also an OH here. Anyway, those OH is in terms of 109.5 degrees. So whatever drawing I have, it should be common to us that these are 109.5 degrees. Okay? So drawing doesn't matter. What matters is we can understand the angles since that's already our LP1. Um, and then your you should only write the other after that because that would still be present, of course, from the cheat sheet. As you can see from that, see here, those bonds there. So single bond now, double bond would be now a single bond, but that would still be there, of course. You have your CH2, you would have your CH2, you would have your CH2, and you would have your CH3. So that is the answer from this one. So not bad. But again, your answer should be in terms of names because ah, that's my LO. The declared LO should be, you can have the nomenclature of that product substance. So this one be 1, 2, 3, 4, 5, and 6. So that would be a 5, 6. Okay, 5 comma 6. 5 comma 6 disin. You should complete it because it's a die. So that should be a decane. Uh, that should be a decanol actually. But if that is there are two, decane to all. Decane to all. Okay? Decane to all. Or I think these are the only I think you only have one name for an ayupak here, since maybe this is the one that they're trying to avoid. Because if you don't have this number, you can just name it as uh, 2 dec uh, 2 decane diol. 2 decane diol. But the OH must be exemplified, I meaning that's why they included in 1986 IUPAC that the OL would be separated from your parent name as the last one, because that is signifying that that is the most important or the parent functional group, the alcohol. So that would be, I sorry, 2 diol. You still have that word diol. So 5,6 decane 2 diol. Okay? Uh, you don't have any other answer because both of that will be an OH. So this is the only answer for this kind of problem. So from the question, 5 decene, your answer should be a 5,6 decane 2 diol. Okay? So that is for this video, guys. I might probably make another one. Anyway, kota na ako ada. I'll still edit and so many things. Of course, the whole day should be over. Retake so that I could have a proper lighting. But anyway, God bless, guys, for our asynchronous class. Thank you for listening.